now that you've gotten into the directions, we can actually determine the strength or magnitude of the force. You have been practicing the direction of the force, but obviously that force would have a magnitude as well. So this is our formula for finding the magnitude. So we have Fm, so that's our magnetic force, okay? Fm, magnetic force. So always in newtons, right? Every force is in newtons. Our Q is our charge of the particle that's moving through the magnetic field. Our V is the velocity that it's moving through the field, and B perpendicular is the magnetic field strength, and here's a new unit, Tesla. Okay, so that magnetic field strength is measured in Teslas. All right, so to do this, an alpha particle is shot between two parallel plates that have an electric field strength of 9.77 times 10 to the power negative 4 Newton coulombs. A magnetic field is applied to the parallel plates so that the magnetic field is perpendicular to the particle's motion. So that's our B perpendicular. So we know that there's actually a force, right? Because it needs to be perpendicular to the motion. Okay. If it's not, then F net equals 0. Okay. Well, and I'll give you another situation here. I'll just keep reading. If the magnetic field strength is 4.9 times 10 to the negative 7 Tesla, what is the speed at which the alpha particle must be traveling so that it passes through undeflected? So it's asking for how much strength would it have to have it not go like woo or down or around. So that means since it doesn't want it to be deflected, F net will be 0 because it's not being pushed up or pushed down. Okay? Now, when we think about F net for these questions, what forces are being applied? Since it's in parallel plates, it's experiencing an electric force. So we have our Fe and we have our Fm. Okay? Now, here, we're assuming its magnetic field is applied in a way that it needs to be undeflected, so the magnetic field and the electric field need to be running opposite here. So since F net is 0, now we can say Fm is equal to Fe for this question. So now what we can do is let's just gather up all of the information we know and what we're trying to find out, and then we'll go from here. We'll use this and we'll expand it into formulas. So we know our electric field strength is 9.77 times 10 to the negative 7 Teslas. Newton coulombs, sorry. Got ahead of myself there. Newton coulombs, and it's B that is in Teslas. So you can put B perpendicular or just B. We know it's perpendicular, so you can have that symbol there. This is 4.9 times 10 to the negative 7 Teslas. And we're trying to find speed. Speed or, so no vector. Or speed. All right, so let's expand this one. If I have Fm, that is equal to Q times V, Q times V times B perpendicular is equal to, now what can I expand Fe into that includes this? What formula has this and Fe in it? Of everything I know. Look on your formula sheet. Yeah, so Fe is then equal to E times Q. Okay. So now what I want to do is I want to solve for V in this question. So I want to solve for V. Since Q is on both sides of the equal sign, once and I'm not adding or subtracting, I can cross Q out. You could have it in your formula, but it's like you put it and divide it over itself, so it's kind of redundant. So now, if I rearrange this, I have V as my speed is equal to E over V. So my V is equal to 9.77 times 10 to the negative 4 Newton coulombs divided by 4.9 times 10 to the negative 7 Tesla.
And then to the negative 7.
Right here,
No, up 9.7.
times 10 to the negative 4.
Down one.
Oh, but I see. Up top you have E is to the negative 7.
Oh, sorry, I miscopied that from our notes. It says 9.77 times 10 to the negative 4. Thanks. Yeah. It says in the question negative 4, but I copied that down wrong. Sorry. Okay, so our speed 1,993.877 meters per second. So we have 3 sig digs, so it's 1.99